Okay, 5-2, day 2. So, you have learned when you have square roots, you cannot add or subtract them unless the radicand, which is under the radical, is exactly the same, correct? Well, it applies here too. You can't do it unless they're exactly the same root and the same radicand. Does that make sense? Okay, so we have to simplify them. So we need to simplify them. What root is the first root you see? Square root. So 20, does 20 have a perfect square in it?
4 and 5.
Well, 4, right? So I could reduce that to 2 squared to 5. How did the 4 become a 2?
Because you get the square root.
Because you have to do what? Not square it. Take the square root. No. Nope. Okay. And then next one.
Yeah, 4.
Okay, but what root do we have now?
Third.
The third root. Okay, so we're going to go through it just step by step on the third root, how we would simplify it. So it'd be 2 to the 4th, right? So we could bring out 1, 2? Everyone following what's going on?
Yeah.
Okay, so minus 2, the cube root of 2, because 2 is left over. Now, could I do 2 to the 4th to the 1/3? Could I do that? And then bring it out that way if I wanted to? Yeah, but these are easy enough. We should be able to think about it, right? Okay, 250. Well, that's 25 and 10, right? So that's 5 cubed and 2. Because it's 25 has 2 5s.
No.
Yes. 25 has 2 5s and 10 has a 5. So it's 5. I said 5 cubed, but I wrote squared.
That's what.
Okay, so 5 cubed times 2. So I can bring out a 5. And then I have the cube root of 2. Minus, can I do anything with the square root of 5? No. So you just have to go through and simplify. Now the only things you can combine are things that are like terms. So like terms means same root and same radicand.
Is radicand the thing that's in the radical?
Yes. Okay, so I have a square root here and a square root here. So square root, check, first thing. Second thing, it has to have the same radicand, does it?
Yeah.
The radicand is 5. You are seeing up there the same thing as 2x minus x. Exactly. You have 2 square roots of 5 minus 1 square root of 5 gives you square root of 5. Does that make sense how I said that?
Yeah.
Okay, because what it really is 2 square roots of 5. That's what I have.
Would be 3.
So the next one I have the cube root, so they're both the cube root, and the radicand's both 2, so can I combine them?
Yeah.
Okay, so I have negative 2 cube roots of 2 plus 5 cube roots of 2, so I have
3 cube roots of 2.
plus or minus?
Plus.
Plus 3 cube roots of 2. So it just takes a little prep before you get there.
Can we try the next one?
Sure. You want to try it on your own?
I would.
They're all square root, so that should be easier. A little.
What's for lunch? Can you look?
I'm recording.
Oh yeah, breakfast. That's right.
Leftover biscuits and gravy from FBLA.
Okay.
Oh, FFA, sorry.
Your chicken.
Can I start? You guys far enough along?
I know like 600.
How many times?
100 times 6.
I have 10, 6 left over.
Okay. I was getting there, but it's taking way too long. silly.
Students from Mr. Myers' class are just getting back, so they should be in your classroom momentarily. Students from Mr. Myers' third period class should be to your class momentarily.
Okay, I have negative 10 squared root of 6 minus 3 squared root of 5. Could I have negative 3 squared root of 5 minus 10 squared root of 6?
Wait, negative 3. What were you saying?
Can I switch it?
Yeah.
I mean,
Can I have the negative 3 squared root of 5 in front?
Yeah.
As long as I take the positive negative with it, right? And there's really no hierarchy. Like, they're both square roots. There's not. Make sense what I'm saying? Okay. So.
would that be
So the only. I know the first part of it. You guys know the first part of it?
No.
3 times above?
Square root of 2. Why can't I just write the square root of 2?
Because that one
3
can't
zeros.
be.
There's no other square root there, is there? So there's no other like term even possible, is there? Okay, so 2,000, how do we want to do that? Well, that's 10 cubed, right? Times 2?
1 cubed.
Yeah.
10 cubes, 1,000.
10.
Oh, yeah.
So I can take out a 10 cube root of 2. Okay, so can these be hard? Or they could be easy, right? Is there a reason why I tried to torture you with your squares and cubes last year?
Mhm.
Okay, 128.
Is
So, like,
6? No.
Well, 4 goes into it at least, right?
Yeah.
Because 4 goes into 28. So it'd be 4 and 32. And 32 is 16 times 2. So I can bring out a 4. So minus 4 cube root of 2. So 10 minus 4 is
6.
6. So plus 6.
what happened to the first 2 you took out?
You didn't take it off. It's still there.
What do you mean?
Like you took out a full. You took out a 2 or something and got.
Square root of 2 is in the problem.
Square root of 2 is right here.
No, in the 128. What was the first thing you tried to factor?
Oh, I took a 4. I did a 4.
Yeah.
So I have 4 and 32. And 32 is 16 times 2. So
Okay, never mind.
you good then?
I think.
Okay. My cube root wasn't working out. Sorry, guys. I had to rewrite it. Okay. Now, the only thing that I would suggest is always try to get a positive in the front if you can.
Yeah.
Here, they were both negative, correct? I could factor out a negative if I wanted to, but that's kind of weird to just do an extra step and you don't need to. Again, the only thing I try to do is make sure I get a negative in the front if I can. That way I don't forget it. Those negative, no, I said negative, positive in the front. Because sometimes when we put a negative, the first term, we forget it's there, right? So if we get the positive there, we don't have to forget about it. Okay, so what do you think I'm going to do here?
Combine. I don't know. Combine. Distribute.
I'm going to distribute. So if there's a cube, like this, a cube root of 7, yes? What's numbers in front of it?
1.
A 1. So whole numbers times whole numbers, radicals times radicals. Got me? If they match the root, you don't have to do anything special. If they don't match the root, we need to have them in exponential form so we can add them by getting common denominators and work with them. These roots match, correct? So we don't have to do anything special. So 1 times 2 is
2.
2 cube roots of
7.
7 minus. Now we're going to have the cube root of 7 times the cube root of 49. Nobody getting what I'm putting down?
2 cube root.
So I'm going to have the cube root of 7 times 49.
43.
You're making it hard, guys.
It's a
7 is, 49 is 7 what?
Squared.
Squared
So
times 7. So the answer is just
7.
7. See how you're making it hard, Carson?
I have no idea what you're talking about.
Okay, we're taking 7 times 49, yes? So isn't that 7 times 7 times 7?
Yeah.
And cube root, you look for sets of 3.
Oh, okay.
So you were making it harder.
I wasn't making it harder.
Yes, you were.
I wasn't.
Okay, so when you multiply the radicals, make sure you're making it easier, not harder. Got it? Make sure you're thinking about those bases and like what you can do with them. Not have to multiply them out and get 343. Just being able to go straight to 7. Because then when I ask you for the cube for 343, your brain's going and you're using your fingers and your toes and got it? Okay, what are you going to do with the next one?
Same thing, you just foil.
Same thing, FOIL, distribute, right? So 2x times 2x is
4x squared.
4x squared. And then I'd have negative 2x square root of 3 and negative 2x square root of 3. So I have negative
4x.
4x square root of 3. And then a negative times a negative is a, and square root of 3 times the square root of 3 is just
3.
3. If you need to show more work, show more work. Got it? Have we done things like this before?
Is that the answer?
Because it just would be multiply. It just says multiply. It doesn't say anything else. If it said solve, we'd said it.
Will we solve it eventually?
If we solved it, we'd solve it here.
Okay.
So it would be square root of 3 over 2. You'd add the square root of 3, divide by 2. So. You got these two. Do them on your own.
Hey.
I'm going to put it back. I just wanted to see how much more we had. Oh, that's wrong. Opposite way. Right? This one's easy.
Oh, I found my notes sheet. It was in my room.
Did you get it in your notebook?
It's in my bag.
Get it in your notebook because you need an extra. Okay, did you get 5 square root of 6 minus 3 square root of 2?
Yep.
Yeah.
How did I get 3 square root of 2?
He's great. It's 8. It's
3 times
square root
6.
of 18.
3 times 6, and there's a 3 and 6, right? Okay, now, why did I say the other one was easy?
Because it's a difference of squares.
It's a difference of squares, and if it's a difference of squares, you square the first and square the second, yes? These are also known as those conjugates, correct? Which we need on the next slide. Difference of squares and conjugates. When I multiply like this, I don't have that radical anymore, do I? Okay, so we can't leave a radical in the denominator, correct? No. So, how did we just get rid of the radicals? We multiplied it by its,
Self.
not itself.
The negative.
It's the what? Well, I just used the word
Conjugate.
conjugate.
What is that though?
The difference of squares of it. It's the same thing, and this sign is different.
The different square.
Okay, the difference of squares. So, we have 1 over 2 plus the square root of 5. If it was just 2 times the square root of 5, I could just multiply by the square root of 5 and be all good, right? But it is not. So I have to multiply by its conjugate. So what?
2 minus square root.
So 2 minus the square root of 5. And then on the top, what am I writing?
I,
I don't know.
I don't either, obviously.
We'll do the same thing on the top, don't
Yep. So 2, oh, this top's easy because it's just 1 in the numerator, right? So we have 2 minus the square root of 5 in the numerator.
over 4.
4 minus 5, which would be,
-1.
this would equal -1. So instead of writing it over -1, we go negative 2 minus the square root of 5.
we? Put in plus.
Or you can distribute the negative and write it as the square root of 5 minus 2. Why did that change?
Because you want the positive in the front.
Yep. So either one of these is okay. I don't care. But don't do this. That's yucky.
That's what I say. If you write it up there, it's wrong. I'm problems.
Yucky. Okay. So we're all done simplifying and this is my answer. Can I stop?
Yeah.
No. On the next one.
Oh.
no.
No. I cannot stop. Why can I not stop?
Because you can't have a root or square
Radical.
root. Radical.
Radical. Can't have a radical in the denominator. So I need to multiply. First thing we should put is parentheses, right? Because who's the person who likes to cross things off randomly?
No.
Noah. Stop it. Okay. So we're going to put our parentheses so Noah doesn't start. I just pointed at Logan. I said Noah and pointed at Logan. I think Noah does it too, though. Don't you?
I do it a lot.
Yeah. Okay, so we're putting parentheses so we don't start crossing random things off, right? And we're going to multiply by the what? What's the magic word? Conjugate. So 1 plus the square root of x. And whatever I do on the bottom, I have to do on the top. You'll usually see me write it one time in the middle. Does that make sense? Because I don't like to write it twice.
So it would be -4x to the square root of x, or what would that say?
Well, not to the, but how about minus 4x square root of x? That looks funny, but yes. I think maybe I would say you could just leave it like this.
Okay.
I mean, I think maybe distribute if you could simplify it more, but doesn't this look worse? Doesn't that one look worse?
Yeah.
So keep it.
Okay, I don't care. I'm not going to, like on that point, I'm not going to say you have to do. Okay? Carson,
11 make a wish.
get off your phone. Your wish is that I didn't see you on your phone. Okay, so your denominator is going to be 1 minus x. Is that your denominator?
Yeah.
Okay, so either one of these, I'm okay with how that looks. I don't know. I don't remember what they do. No, they distribute it. They do this, but like I said, I am not going to make you do that. If you can simplify something out of the square root, then certainly do it. Make it look better. But does this boxed one look better? Looks gross. Oh, and Noah and Logan, you better put parentheses around that bottom. Because we know what you guys start doing. Ooh, here's an X. There's an X.
It's not my fault I'm not a mathematician.
Here's an X for everybody. Okay, one last problem on your own.
Let me try it.
Guys, let me know when I can start.
You can start, yeah. I definitely won't copy down what you have.
Yeah, I'm not going to start that quick. Not for you. You two. It's just both of you two today.
Always has been.
Is that
Don't I got a
segregation?
higher grade than you?
Logan.
Exactly. You're segregating me.
Logan.
Wow.
No, I'm not. No clue. Put your parentheses, both of you,
Where?
around the numerator and the denominator.
Or
C2.
This looks horrible.
I'm so confused, yeah.
Why? You're just distributing it.
I know, but it looks gross.
Well, yeah, it's not very pretty looking, I guess. The denominator is easy.
Mm-hmm.
Huh.
What we squared is 6. You multiply the square roots.
Mm-hmm. Does this one look pretty?
Mm-hmm.
No.
Is it because there's nothing I can combine, is there? But was it harder?
Yep.
No,
it's
it
good
just-
combined.
It just looks worse because I can't condense it any. Okay. So,
Wait, you can even put another one.
nope. Now, you had 3 problems you didn't do yesterday. Do you want to do them on your own or do you want to do them together real quick?
Together.
I don't want to do them all.
I'll just.
Well, you are doing them.
Okay, I'll do that.
Okay, so take out your assignment from yesterday and we'll do the 3 you
If we
did.
do them together, do we have to turn it in again?
What numbers are then? So I can.
10, 11, 12. No, 10,
No.
8, 9, 10, 12.
9, 10, and 12. Yeah, if you just take a picture of that part, you can add it.
What page? Would I send it?
Yeah, you could turn around since you didn't write it down yesterday.
What did I do to you this, Mick?
You didn't do anything. I'm just being honest.
Exactly. You didn't do
Okay, so 9 is the square root of 63
Not the function of the
minus the square root of 700
No, it is not the right page.
minus, well, I'm writing it right now. It's the square root of 112. So they're all square roots, right?
Mm-hmm.
But I need to do what? So they're all the same root. Now I need to do what?
Math?
You right.
What do I need to do with them?
The one thing where you take it out of
So I can just simplify it, right? Okay. So 63 is what times what?
69.
9 times 7, so that's 3 square root of 7 minus
10 square root of 7.
10 square root of 7 because it's 100 times 7, right?
I don't know what this is.
Now you guys are getting better at looking for the perfect squares, aren't you? Okay, 112, I know 4 goes into 112 and it's 4 perfect square.
Yeah.
Yeah, but I'm sure more. Okay, so 4 goes into 11 twice and 8,
Doesn't.
right?
Yeah.
Okay. Oh, it should be 8.
Well, okay.
4 times
Because
28.
4, you had 3, so 32, so it's 8.
Okay.
Okay, so then 4 times 7, so I can bring out a 4. So now can I combine them all?
Yeah.
So what do we get? Negative 11 square root of 7?
So it's 4 times 7, or what is it that equals 112?
4 times 4 times 7.
No.
Because 4 times 28 was 112, and 28 is 4 times 7.
16 times 7.
Yeah, so 16 times 7 if we would have known our 16 times tables. Darn it.
I know my 7 times tables. 10.
You know your 7s?
Yeah.
Good. You don't even know 11 or 12? Okay, 10 is square root of 5 times the quantity 6 plus the square root of 2. What am I going to do?
Distribute.
So I get 6 square root of 5
Mm-hmm.
Plus square root of 10.
plus the square root of 10. Now, you should start looking and say, oh, does 5 and 2 have any common factors? No, so I'm just going to multiply them anyway. Okay? So you should almost start looking.
Is that the answer?
Yep, that's it. 12. is the square root of 7 divided by square root of 5 plus 3. And what should I put around that denominator? Parentheses. So what's wrong with it?
You gotta bring it up top.
What?
Gotta bring it up. There's a radical in the denominator.
The radical in the denominator. So I'm going to multiply by.
Square root of 5 minus 3.
Which is known as the what?
The conjugate.
Conjugate. Good job. See, I always just write mine off like that. So this is going to be 5 minus 9. So what, 4?
Negative 4.
Oh, yeah, negative 4.
And the top is square root of 35 minus 3 square root of 7.
Now, I personally don't like the negative down there. So could I bring it up and put 3 square root of 7 minus the square root of 35
Yeah.
Sure.
over 4?
Do you have to do that?
Nope. I'm just saying I personally do not like it. Okay, so your assignment today
Can I turn this
is 19 through 48. So guess what you're doing? Everything from yesterday and today.
Yesterday's I don't understand.
What don't you understand?
I don't know, just confused.